series. Remember, if we say series, we mean infinite series, so we could also think of this as the sum of an infinite geometric series. Now we know that for a partial sum, S of n is equal to a sub 1 times, that is the first term, times 1 minus r to the n, all divided by 1 minus r. Great, you say. That then implies what? S of infinity equals 1 minus r, a sub 1 times 1 minus r times r to the infinity times 1 minus r. But that's not very interesting, or is it? Well, if we were to take, say, 2 and raise it to the infinity power, we would get, well, a really big number, aka infinity, which means we'd have 1 minus infinity, which is some really small number, divided by 1 minus 2, which is a negative. So we get a positive, we get infinity, which is, well, boring. Unless r to the infinity equals 0. So remember, this is an exponential equation. And if you think about the long-term behavior of what's going on here, it would mean that what? For any given thing, either the values get infinitely large, if it's r, that is, the base is greater than 1, or if r is less than 1, like say we're multiplying by 1/2, then eventually the numbers will get so small as to be equal to 0. What does this mean? It means that if we look at the formula, if r is less than 0, that is, if r is like 0.5 or something like that, now we probably should say, and I should be careful here, if the absolute value of r is less than 0, then r infinity does tend towards 0. Think like exponential decay. So what this means is, if we're looking at the sum formula, then what? Well, S of infinity would be simply what? This would be my mouse not cooperating quite. S of infinity would be a sub 1 times 1 minus, well, r to the infinity. But r to the infinity does tend towards 0. It'd be 1 minus 0 over 1 minus whatever r is. 1 minus r is some number. It's going to be some positive number, which means that we really get what in the end? When r is less than 0, the sum for an infinite series, or sum for a geometric series, is this. So for example, if I have S infinity of a sub n equals 2 times 0.2 to the n minus 1. So I needed to establish, is this worth wasting my time actually thinking about, or is it really just infinity? Well, 0.2 is less than 1. The absolute value is less than 1, which means that S of infinity is simply going to be the first term divided by 1 minus 0.2, or 2 divided by 0.8. Here, I like fractions, so here's what we're going to do. 8 is, that's 8 tenths, right? And we divide by a fraction, 2 times 10 over 8. So that's what? That comes 2, so this is 10 over 4. 10 over 4 is what? What is 10 divided by 4? 2.5. Now you could have just stuck this in the calculator, but either way it means that as we approach infinity, the sum approaches 2.5. That it has some constrained value it's approaching. So find the sum from 0 to infinity of, so this is just another way of writing it, right, using summation notation. So what does this mean? Well, here n equals 0, so we got to be careful. What's our first term? 3 times 1/4 to the 0 minus 1. What is that? Well, that's 3 times 1/4 to the negative 1, but that's the same as what? 3 times, oh, that takes the reciprocal. So this is the same as 3 times 4. In other words, our first term is 12. So our first term, remember S of infinity, when we're talking about this, the a sub 1, may not be a sub 1, in this case it's a sub 0, but that is that first term, which is in this case 12 divided by 1 minus 1/4. That's right, boys and girls, fractions, which of course, as we know, are our friends. This is 3/4. That's same as 12 times 4/3, conveniently enough. Three goes into, whoops, I can't multiply apparently. I can divide, but I can't multiply. 3 goes into 12 4 times, so it reduces, and 4 times 4 is 16. So the sum of this particular series is indeed 16. That's it.